Hello, and welcome to the TechZero Python Learning course. In this video, we're going to be covering the topic of collections. Collections are analogous to arrays in other programming languages, and they can be used to store multiple items in a single variable. There are four types of collections. There are lists, tuples, sets, and dictionaries, each with their own particular use case. First, we're going to cover lists. Lists are an indexed collection of items. The items in the list are ordered by their index. They can be changed, and you can have duplicate values within a list. You can put any data type into a list, including other lists. You can create a list by creating a variable, say myList, and using the following syntax, one of the two. You either use square brackets, and you say like 1, 2, 3. Then we can add a string in there. Then we can add say a floating point value. And that'll be just fine. No problem there. If we print myList, we'll see everything is exactly as we put it. No problems at all from the interpreter. You can also create a list using the list constructor, list constructor, which is basically the same thing, except you use a double set of brackets. As you can see, still works too. Please note the double set of brackets. If you try to use a single set of rounded brackets, you're gonna have a problem. That's because the thing that you pass to the constructor is what is known as a tuple, which we'll be covering next. When you want to access something in a list, probably should have kept that list now that I think about it. When you want to access something in a list, you use its index. Indexes start at 0 and go to whatever number of items are in the list minus 1. So if we want to access the first item, say myList square bracket 0. The square brackets are how you use an item's index to access it. So we print that. We get 1, which is the first thing we have in the list. If we do index number 2, keep in mind that since indexes start at 0, you have 0, 1, 2. We should be getting 3 as the output, and we do. You can also use something called negative indexing. I find this to be pretty useful. If you want to access the final thing on the list, you pass in the index -1. However many items you have in the list, just throw some random numbers in there to fill it out. No matter how many items you have in the list, you will always access the very last one using -1. If you go to -2, you'll get the second to last item. -3, third to last, and so on. You can also access a range of indexes using the colon operator. So let's say we do this, access it with this. What will this do? This will access indexes 1 through 4. It's important to note that this second number here will be excluded in the indexes accessed. So what we get here is index 1, which is right here, through index 4. So 1, 2, 3, 4, and that's what we get down here. Now if you exclude one of these numbers, say the one on the left, if you exclude the number on the left, you will access indexes between the start of the list and one before the second number, as we see right here, 1, 2, 3 string 0.5. If we say, let's make the left number 3 and take out the right number, that will access indexes between 1, 2, 0, 1, 2, 3, and all the way to the end of the list, as we can see. Negative indexing can also be used with the colon operator. So if we say between -5 and -1, that will give us 56, 6, 5, and 2, excluding the last thing, which is -1. Keep in mind that that will always be excluded. If you try to access using negative indexing from something, some arbitrary index within the list all the way to the end, and you use -1 as this right side here, you will still exclude the final value. If you want to get that final value in there, all you got to do is just remove the number on the right, and you'll get it, no problem. Now, how would you check to see if something is in a list? If you didn't want to iterate through every single item in the list and check it against something you're trying to find out is or is not in the list, is there a way to do that easily? There sure is. using the in keyword. So let's say we wanted to find out if the string is in my list. Say if string in my list, print it is. And you'll see that it sure is. Now if we try to find strong in the list, this will not print out. It's not in the list. It doesn't return true. It's a very handy way of checking to see if something is in a list or not. Let's say you want to change something in a list. You can do that by accessing its index. My list is equal to 1, 2, 3. Let's say change string and make it strong. We then print my list 3. We will see it has been successfully changed. If we print the list out in its entirety, we will see, indeed, there it is, exactly where string was. Now let's say we wanted to add something into the list. How could we do that? We have a couple options. We can use the insert method, say mylist.insert. And we give it an index and something to add in. Let's say add me. This will add the string add me into index 5. And everything that was either at or after index 5 will be shifted to the right. So now we see what used to be index 556 has now been shifted over, and now the string add me is in its place. If you want to add just to the end of the list, instead of worrying about what index to put in and where to stick it, you can just use the append function. Add me to the end. And there we go, right then. Now let's say you had 2 lists and you wanted to combine them. You want to take everything that was contained in the second list and just stick it onto the end of the other list. You can use the extend function to get that done exactly as you like. mylist2 equal list2 stuff. More stuff. We just call the extend function on mylist and pass it mylist2. Then we print out my list. The stuff that was in mylist2 has just been plonked onto the end there. The extend function can be used with any iterable object, which includes other lists, as we've seen, tuples, as we will see, sets, dictionaries, etc. Anything that is an iterable object, you can extend it onto a list. To remove an item from a list, you use the remove function, as you'd probably expect. So let's say we remove the string. It's gone. Everything is shifted over to the left to take its space. Their indexes have been changed appropriately, and the string is no longer a part of my list. If you want to remove based on the index of an item, you can use the pop function. Let's say we pop index 6. 0, 1, 2, 3, 4, 5, 6. That will remove the value 234. And as we see here, it is gone. If you do not give an index to the pop function, it will remove the final item in the list. The thing that was most recently added will be taken off. You can also use the del, short for delete, keyword to delete either a specific item in the list based on its index. I'll see this will remove 0.5 from the list. Or if you just say del my list, it'll delete the list entirely. And if we try to print it out afterwards, it's gone. My list is not defined anymore. If we want to keep the list without deleting it, but we do want to delete all the contents, we can call the clear function on it, mylist.clear, and we will see empty list, but my list is no longer undefined. If we want to see the length of a list, we can use the len function, short for length. You just pass the list to the len function. We print that out direction, we'll see that there are 12 items in the list currently. which matches up with our variable explorer, my list size 12. Now this next thing is a little more on the advanced side, but it's something called list comprehension. List comprehension is a way for us to build a list from an iterable using one line of code. In order to do that, we're going to do list comp is equal to the following syntax. I'm going to stick this just so it doesn't yell at me while I'm typing it out. Is going to be in the following format. It's going to be list name is equal to square brackets expression for item in iterable if condition is equal to true. The keywords in this are for, in, and if. Expression, item, iterable, and condition are all things that you set up. So let's see what we can do about this. Let's say that we want to have a list of names real quick. John, Jack, Jane, and Jerry. So if we name for name in names, if, let's say name, first character of name is J. How about that? And then we'll print out list comp. And what this does, before I go ahead and print that, I want to make sure that each of this gets explained. Name for name means for every item in names, we're going to call it name. We're actually going to do something to this first one, just so the fact that it's called expression comes across. We're going to change it to lowercase. Also, don't forget to remove the list, so we're going to just print out the number of items that get added to it. So for every item in the iterable names, we're going to call each thing name as we pull it out one by one, and we're going to apply some expression to it. In this case, it's going to be name.lower. We're going to take whatever we pull out and we're going to change it to lowercase, just to do something to it. We'd also change it to uppercase or just leave it totally unchanged. This just demonstrate that this expression is where we can actually do something to manipulate the thing that we're pulling out of the iterable before we stick into this new list called listcomp. So we have name.lower for name in the iterable names if the first character in name is a J. And if we do this, we'll see that we have all lowercase John, Jack, and Jane. Only John, Jack, and Jane met the condition where the first character was a J. And so they were the only things that were added into this new list comp. If we add another thing in here, Mac, it will also be excluded for the same reason. If we add another name J, it will get added. List comps, while being a little confusing at first glance, are fairly powerful for making a list out of some other iterable quickly and easily, while also filtering it based on some condition you set and potentially manipulating the items in that iterable if you need to. Next up are tuples. Tuples are very similar to lists in many ways, but are very different in other key ways. I have a couple set up here for later examples, but we can see that the way that you create a tuple is by using rounded brackets instead of square brackets. Similarly to lists, you can use the tuple constructor, still needing the double brackets, but that will also create a tuple just fine. Tuples are a collection of items that are accessible via their index, but are unchangeable. Items cannot be added, removed, or changed from a tuple. Another little wrinkle with tuple is if you want to make a tuple that has a single item in it, say we want to stick the word hello into it, you need to have a comma after the one item. If you put no comma there, it'll give you a problem. It will not properly create the tuple. So make sure to put a comma after the first item no matter what, but especially if you want to have a tuple with a single item in it. A lot of things with lists carry over to tuples, such as the length function, len. You can put a len around this if I was printing that out, and it would print out the number of items that were in the tuple. You can access items in a tuple using indexing, access but not change them, and regular, negative, and ranges of indices also apply here. Now, while a tuple is unchangeable, you can convert it into a list, change the list, and then convert it back into a tuple. You can do this for either adding, changing, or removing an item from a tuple. So let's say we want to add a color to colors. You'd say color list is equal to list colors, and say color list dot append, let's say cyan. And then we set colors equal to tuple color list. We print out colors now. We'll see now has that on the end of it. While we did not change the original tuple, we created a new one and reassigned that one to the label colors. It's kind of a roundabout way to do it, but usually if you're using a tuple, you're expecting to not have to change or remove anything from it. While you can't use the del keyword to delete items in a tuple like you could a list, you can still use it to delete a tuple outright. Now, when you create a tuple, it's called packing a tuple. Likewise, we can unpack a tuple. Unpacking a tuple places the values within the tuple into a number of variables. In this case, we're going to unpack rocks. So let's say we want to put everything in rocks into its own variable. Let's say we want to have sedimentary, metamorphic, and igneous. That is all we have to do to unpack the tuple rocks. We see in our variable explorer here, igneous is set to obsidian, metamorphic is set to slate, sedimentary is set to sandstone. The order you place these variables here are the order in which they are unpacked from rocks. In this case, 0, 1, and 2, 0, 1, and 2. If you want to unpack tuples into a list, let's say we wanted to unpack colors, and you say to yourself, well, black is really a shade, but everything else are hues. We use the asterisk. And otherwise, it's the same as unpacking it before. We'll run that. And we'll see we have shade is set to black, and hues is set to the list of red, green, blue. Now you might wonder what happens if you have an asterisk on the first one and no asterisk on the last one. How does it know how many to unpack? Well, let's say that we want to have a really specific list that contains red and green. And then the last item is blue, so we'll stick blue there. It will unpack items from the tuple until there are as many remaining items in the tuple as there are remaining variables to be unpacked. So we do this, we'll see that we have blue is blue, we have shade is black, and we have red and green is red and green. It's because we have 3 items here, only one of them is designated to be a list. We have shade, we have 1 item on each side of the list. It'll unpack 1 thing for shade. It'll unpack as much as it can in the center until there are as many items left in the tuple as there are remaining variables, in this case 1. So it'll leave the last variable for that. Additionally, you can also use the in keyword like you could a list, and in fact for just about every collection that we're going to be going over, the in keyword will work. So we say if blue in colors print blue. And we will see. So it does. Next up are sets. A set is an unordered, unchangeable collection of items. Unlike a tuple, you can add or remove from a set, but you still cannot change existing items within a set. You create a set using curly braces. So let's say we have a set 2, 4, 6, 1, and 3. Why not? To add to a set that is already existing, you say mySet.add. And then you just add in whatever you want. In this case, we're going to add in a 5. In order to access items in the set, because it is unindexed like a list or a tuple, instead of using an index to access a specific item, you would either have to loop through it with a for loop, or use the in keyword like you would with a list or a tuple. So we say if 5 in mySet, print yes. It's in the set, and so we print yes. If you want to remove something from the set, you use either the remove or the discard method. They function almost identically, except the remove function will raise an error if what you try to remove is not found in the set, and the discard function will not. So let's say we want to remove, say 3. mySet.remove 3. Print mySet. And we'll see 3 is no longer in the set. Like a list, if you use the clear function, it will remove all items from the set. You can also use the del keyword to delete a set outright. My set is not defined now. Now, as the name set implies, there are many set operations that are available to us through Python. Our options include union, intersection, difference, is subset, is superset, and is disjoint. And these do exactly as you might expect them to do. If we want to say create a new set, set mySet3, and you set that equal to mySet.union mySet2, that will return a set that contains all items contained within both sets without any duplicates. So it'll be 2, 4, 6, 1, 2, 3, 4, 6, 10, 12, 13. If we print mySet3, we'll see that's exactly what we have. If we do mySet.intersection mySet2, that will return a set that contains only the items that are contained within both sets. So in this case, it's just 4 and 6. If we do difference, that'll return a set that contains only the things in set 1 that are not also in set 2, and so on. We can do is subset, is superset, and is disjoint, which will return Boolean values, I believe. Call is it? We'll say is superset. Be capitalized. Nah. And we'll see it's false. Same will be the case for subset, although we can, let's make a set that it is a subset. Sub is equal to, let's say, 2, 4, 6. So let's see if my set is a superset of sub. It is. Go figure. Likewise, that means that sub is a subset of my set. And is disjoint returns true if there are no items that are shared between the sets. Last but not least are dictionaries. A dictionary is a collection that stores data in a key value pair, as seen here. I got a couple set up just so we can get into it a little bit quicker. Dictionaries are unordered, they are changeable, but they do not allow duplicate keys, as we will see why shortly. You create a dictionary using 2 curly braces, and then key value pairs separated by a colon, and each key value pair is separated by a comma between. As implied by the phrase key value pair, the key is on the left side of the colon, and the value is on the right side. You access items in a dictionary via the key, which is why you can't have duplicate keys. You can do so either by using the index notation. So if we print myDict z1, 2, 3, 4, 5, 6, 7, that will print out the value associated with the key z1, 2, 3, 4, 5, 6, 7, which is John Doe. You can also use the get function to achieve the exact same thing. As you see, the keys function will return a list of all the keys in a dictionary. So we say keys is equal to myDict.keys. Let me print the keys. We'll see dict keys and then a list of the 2 keys that exist within our dictionary. Likewise, the values function will retrieve a list of all the values. Dict values, John Doe, Jane Doe. The items function will return each key value pair in the dictionary as tuples in a list. So we say items, dict.items, and print out items. We'll see dict items, and then we'll have our tuple with our key and our value, and then the next tuple with its key and its value. The values in a dictionary can be any data type, including other collections, even another dictionary. A dictionary within a dictionary is called a nested dictionary. Fun fact. You can also use the in keyword to check to see if a key exists in the dictionary. And you can change the value of an item by using its key. Just code that real quick. And let's say my dict, say Z1, 2, 3, 4, 5, 6, 7. And we'll set that from, we'll change the value John Doe to Jack Doe. And I'll print out the dictionary. And we'll see is now Jack Doe. You also do the same thing with the update function. Say my dict.update. And you send to it a key value pair. 3, 4, 5, 6, 7. Perhaps I should have chosen shorter keys. And we'll do that way. Print out the dictionary. And it has been successfully updated. You can also use the update function to add in a new entry to the dictionary. So you can see if the key doesn't already exist, when you pass it into the update function, it will create a new entry for us. So we can also add a new item to the dictionary just by accessing a non-existent key. So I just want to point out here that a key doesn't necessarily need to be a string. I'm going to use a number for this next entry. I have strings as my first two examples, but it doesn't mean it has to be a string. So let's say we have key being 5 with the value Jackie. Print that out, and we'll see we now have associated with key 5, the number 5, not string 5, is the name Jackie. Now if you want to remove an item from a dictionary, you can use the pop function. Let's say we want to remove our newly added Jackie. Say pop 5 is the key that I'm removing, and it's no longer there. If we pop Z1, 2, 3, 4, 5, 6, 7, we get rid of John. We can also use the del keyword like we had before. And that should, not that, needs square brackets. And John goes that way too. The clear function will again delete everything in the dictionary. And the pop item function will remove the last inserted item. So if we want to add Jack in and then remove them later, say my dict.pop item. No longer there. Last thing that was entered now has been popped.